Good morning students. Today we are discussing some important notes of differentiability, also some questions of differentiability and continuity. Last class already we discussed the relationship between continuity and differentiability. That is, every differentiable function is continuous, but the converse may or may not be true. That means a function is differentiable, then it is continuous, but a continuous function may or may not be differentiable. सबु जाक डिफरेंशियल फंक्शन को आम कौन कह कंटिन्यूस कहवा, कि सबू कंटिन्यूस फंक्शन को आम डिफरेंशिएबल कहीपर ना. आम चेक करिया पड़ो, जदि कंटिन्यूस हो मीन्स अगेन चेक करिया पड़ो डिफरेंशिएबिलिटी. तो मुझे तुमको कही कंटिन्यूस एज ए कंटिन्यूटी एज ए 9th क्लास, डिफरेंशिएबिलिटी एज ए 10th क्लास. If a student passed in 10th class, that means already passed in 9th class. That means a function is differentiable. 10th class means differentiable, 9th class means continuous. So 10th pass means 9th pass. That means differentiable means continuous. Next, 9th fail means 10th also fail. 9th fail means discontinuous, means a function is discontinuous, then function is non-differentiable at the given point. जदि गोटे फंक्शनटा कंटिन्यूस नुहे से डिफरेंशिएबल नुहे. नेक्स्ट, जदि गोटे फंक्शनटा कंटिन्यूस अर्थात 9th पास, तो आम कहीपरि स्टूडेंटा 10th पास कि ना. तो से हमको अगेन टेस्ट करिया, अगेन एग्जाम देवा पड़े 10th क्लास एग्जाम. तो इफ ए फंक्शन इज कंटिन्यूस, दैट मीन्स इट इज मे और मे नॉट बी डिफरेंशिएबल, हो पारे ना हो पारे. तो से वी नीड टू टेस्ट वेदर द फंक्शन इज differentiable or not. Similarly, if a function not differentiable, जो फंक्शन डिफरेंशियल नुहे, तो अर्थ 10th फेल, तो अर्थ आम कहीपर 9th पास की फेल. तो अगेन आमको चेक करिया पड़े 9th में, टेस्ट करिया पड़े 9th क्लास में. तो अर्थ ए फंक्शन इज इफ ए फंक्शन इज नॉट डिफरेंशिएबल, वी टेस्ट वेदर द फंक्शन इज कंटिन्यूस और नॉट. Some important note, some important note. 1. Every constant function is differentiable everywhere. Everywhere means on real number R. 2. Every polynomial function also differentiable everywhere. 3. Sin x cos x also differentiable. 4. e to power x, a to power x also differentiable everywhere. 5. 10x comma cot x comma sec x and cosec x are differentiable in their respected domain. So 10x and sec x are differentiable in the domain r minus odd pi by 2, r minus odd pi by 2, because tan means sin by cos, sec means 1 by cos. When cos is equal to 0, tan and sec both are not defined. So cos is equal to 0, cos टा कोड 0 ना एवरी ऑड पाई बाय 2. तो रियल नंबर आर आम ऑड पाई 2 माइनस करदबा ताहले कोन हबो tan and sec both are defined. तो tan and sec डोमेन हला r minus odd pi by 2. cot x and cosec x. Cot means cos by sin, cosec means 1 by sin. So if sin x is 0, then cot and cosec are not defined. So sin x 0 when x is equal to n pi. तो रियल नंबर r हम n pi माइनस कर दबा ताले cot and cosec are defined. Therefore tan x, cot x, sec x and cosec x are differentiable in their respective domain. 6 log x is differentiable on 0 to infinity. This is the domain. X greater than 0, 0 to infinity. So log x is differential on 0 to infinity. 7 1 by x not equal to 0, also differentiable everywhere except 0. 8 sum of two differential function is differentiable. Sum of two differentiable function is sum of two differential function may or may not be differentiable. Sum or difference of two differential functions. Sum or difference of two differentiable function may or may not be differential. May not be differentiable. May not be differentiable. Example, let f of x sum or difference of two differential function is differentiable. Sum or difference of two differential function at x is equal to a is differentiable at x is equal to a. Example दे दियो. Give an example of a function. Give an example of a function. Give an example of a function whose sum of two functions whose functions they are non-differentiable at x is equal to x0, but their sum is differentiable at x is equal to x0. Answer: let f of x is equal to x minus mod x is non-differentiable at x is equal to 0. G of x is equal to x plus mod x is non-differentiable at x is equal to 0. But fx plus gx is equal to x minus mod x plus mod x is equal to 2x is differentiable at x is equal to 0. Differentiable at x is equal to 0. Next, some note. Next, 8. Mod of fx is non-differentiable at x is equal to a if f of a is equal to 0. Mod of fx is non-differentiable at x is equal to a if f of a is equal to 0. Example: mod of x minus 1 is non-differentiable at x is equal to 1. Mod of x square minus 4 is non-differentiable at x is equal to plus or minus 2. Mod of x plus 3 plus mod of x minus 7 is non-differentiable at x is equal to minus 3 and 7. So mod of fx is non-differentiable at x is equal to a if condition f of a is equal to 0. जोटी f of a टा 0 हम जोटी mod टा 0 हम से जगह रे फंक्शन टा नॉन डिफरेंशिएबल. तो mod x minus 1 is non differentiable at x is equal to 1. But these are continuous. Continuous at x is equal to indicated point. These are non-differential but continuous. But these are continuous at x is equal to indicated point. Okay. Next. Next, 9 number 9 square bracket fx is differentiable, continuous and differentiable. Continuous is continuous and differentiable at x is equal to a if f of a not is equal to f of a does not belongs to integer and discontinuous if f of a belongs to integer. Discontinuous and non-differentiable non-differentiable if f of a belongs to z. F of a belongs to z. Example: square bracket x is discontinuous it is continuous at x is equal to at x belongs to z, means discontinuous at x equal to 1, discontinuous and non-differentiable at x belongs to z. X is equal to 1, at x equal to 1 non-differentiable, at x equal to 2 non-differentiable discontinuous, at x equal to 3 non-differentiable and discontinuous, at x equal to minus 1 non-differentiable and discontinuous. Square bracket 2x plus 1 is discontinuous and non-differentiable at x is equal to or 2x plus 1 belongs to z. That the 2x plus 1 is equal to n belongs to z. So x is equal to n minus 1 by 2, n belongs to z. So n is equal to 0, minus half, x is equal to minus half, it is non-differentiable, x is equal to plus half, it is non-differentiable, x is equal to minus 3 by 2, it is non-differentiable. So for what value of x it is integer. For what value of x it is integer, in that case function is discontinuous and non-differentiable. Discontinuous and non-differentiable. Other than it is continuous and differentiable. Other than it is continuous and differentiable. Continuous and differentiable. Now test the continuity and differentiability of the function f of x is equal to mod of x minus 2 plus mod of x minus 3 at x is equal to 2 and 3. At x is equal to 2 and 3. Here f of x is equal to mod of x minus 2 plus mod of x minus 3. At x is equal to 2. So check the differentiability at x is equal to 2. F of 2 is equal to 2 minus 2 ra mod plus 2 minus 3 ra mod, 0 minus plus minus 1 ra mod is equal to 1. Minus 1 ra mod plus 1. F of 2 minus h, put x is equal to 2 minus h, 2 minus h minus 2 ra mod plus 2 minus h minus 3 ra mod is equal to 2 to cancel, minus h ra mod plus 2 minus 3 minus h minus 1 ra mod. So is equal to the plus h, minus h ra mod is plus h. This also h plus 1. Minus h minus 1 negative, तार मोड टा कौन आसीबो पॉजिटिव. f of 2 plus h, तो 2 plus h minus 2 ra mod plus 2 plus h minus 3 ra mod, तो 2 to cancel, तो is equal to h ra mod plus h minus 1 ra mod is equal to h. h minus 1 is negative value. h minus 1 is negative value. So this is minus of h minus 1. Minus of h minus 1 is equal to 1. Is equal to what? 1, because mod of x is equal to x when x greater than or equal to 0 and minus x when x less than 0. So h minus 1 is negative value. So h minus 1 is negative value. So x is equal to h minus 1. So minus of h minus 1. Minus of h minus 1. So differentiability तो LHD at x is equal to 2. LHD at x is equal to f dash 2 minus is equal to what is the formula? Limit h tends to 0. F of a minus h, a means 2. F of 2 minus h minus f of 2 divided by minus h is equal to limit h tends to 0. What is f of 2 minus h? F of 2 minus h is h plus 1. H plus 1. That is 2h plus 1 minus f of 2. F of 2 is 1. F of 2 is 1 divided by minus h. 1 cancel. So limit h tends to 0. This is 2h by minus h. H cancel is equal to limit h tends to 0. This is minus 2. So minus 2 limit of constant is equal to constant. Therefore f dash 2 minus is equal to minus 2. F dash 2 minus is equal to minus 2. Similarly, next to find f dash 2 plus f dash RHD at x is equal to 2. F dash 2 plus is equal to limit h tends to 0. F of 2 plus h minus f of 2 divided by plus h. So is equal to limit h tends to 0. F of 2 plus h. F of 2 plus h is 1. F of 2 plus h is 1 minus f of 2 also 1 divided by h is equal to limit h tends to 0. 0 by h. H is small positive number approaches to 0. So 0 by h is equal to 0. So limit h tends to 0. 0 by h. H is not 0 but approaches to 0. So 0 by something is equal to 0. So limit of a constant is equal to 0. Therefore f dash 2 plus is equal to 0. As f dash 2 minus not is equal to f dash 2 plus. So f of x is non-differentiable at x is equal to 2. At x is equal to. Similarly, we can prove at x is equal to 3. At x equal to 3, f of x is non-differentiable at x equal to 3 also. Similarly, in this case we can check. In this case we can check f of x is differentiable or not. Differentiable not means same case asibo f dash LHD asibo gote value, RHD asibo gote value. So they are kana non-differentiable. अलग अलग वैल्यू आसो और चेक करदे. नेक्स्ट चेक द डिफरेंशिएबिलिटी एट एक्स इज इक्वल कौन ना कहल. सो दिस इज द एट एक्स इक्वल टू. नेक्स्ट चेक द कंटिन्यूटी ऑफ द फंक्शन एट एक्स इज इक्वल टू 2. चेक द कंटिन्यूटी. चेक द कंटिन्यूटी at x is equal to 2. LHL is equal to limit x tends to 2 minus fx is equal to limit h tends to 0. F of 2 minus h is equal to limit h tends to 0. What is f of 2 minus h? F of 2 minus h is 2h plus 1. 2h plus 1. So put h is equal to 0. So 0 plus 1 is equal to 1. RHL limit x tends to 2 plus fx is equal to limit x tends to h tends to 0. Sorry, limit h tends to 0. F of 2 plus h is equal to limit h tends to 0. What is f of 2 plus h? 1. The limit of constant is equal to constant. Therefore LHL is equal to RHL is equal to f of 2. F of 2 is 1 is equal to all are 1. So this implies fx is continuous at x is equal to 2. Fx is continuous at x equal to 2. So fx is continuous at x equal to 2 but fx is non-differentiable at x is equal to 2. X is equal to 2 re non-differentiable but at x is equal to 2 re continuous. Similarly, we can test at x is equal to 3 also. Similarly we can test at x is equal to 3 means x जगह 3 पुट करिवो एटी x जगह कोन पकेबो 3 पकेबो और 3 माइनस h बाहर करिवो 3 प्लस h बाहर करिवो चेक करिवो डिफरेंशियलिटी एज वेल एज कोन कंटिन्यूटी चेक करिवो तो एट x इक्वल 3 रे मध्य नॉन डिफरेंशियल बट कंटिन्यूअस एट x इक्वल 3 रे कोन हो फंक्शन दा नॉन डिफरेंशिएबल एंड कोन कंटिन्यूअस. नेक्स्ट क्वेश्चन नेक्स्ट वन check the continuity and differentiability of the function f of x is equal to square bracket x square plus 1 at x is equal to minus half. Test the continuity and differentiability of the function f of x is equal to square bracket x square plus 1 at x is equal to half at x is equal to minus half. Solution given f of x is equal to x square plus 1 square bracket तो f of minus half square plus 1 is equal to square bracket 1 by 4 plus 1 so this is 1 point something square bracket 1.25 so is equal to 1 so 1.25 does not belongs to integer z therefore it is continuous habo as well as कोन हबो डिफरेंशिएबल हबो एंड डिफरेंशिएबल ला सब बेले 0 ही आसीबो जदि स्क्वायर ब्रैकेट फंक्शन डिफरेंशिएबल होउजी तार वैल्यू कोन आसीबो 0 कहीं ना एई वैल्यू दिस वैल्यू does not belongs to z so fx is continuous हबो आ कोन हबो एंड डिफरेंशिएबल मध्ये हबो f of minus half minus h is equal to put x is equal to minus half minus h रो स्क्वायर प्लस 1 तो is equal to square bracket 1 by 4 plus h square plus h a square plus b square plus 2ab plus 1 so this value also 1 कहीं 1 point something 1 plus point something is equal to 1. Next f of minus half plus h is equal to minus half plus h whole square plus 1 square bracket this is also 1 plus something 1 plus this is plus because our square is there na so this is positive value so 1 plus something is equal also 1 तो LHD test for differentiability at x is equal to minus half तो first to find LHD at x is equal to minus half f dash minus half minus use the formula limit h tends to 0 what is the formula f of a minus h f of a what is a is minus half f of a minus h minus f of a divided by minus h so is equal to limit h tends to 0 f of minus half minus h f of minus half minus h is what is the value this is 1 minus f of half f of minus half also 1 so this is 1 divided by minus h this is limit h tends to 0 1 minus 1 0 by minus h is not is equal to 0 but approaches to 0 means minus h means very negligible value negative value minus h is positive minus h is negative तो minus h approaches to 0 but not is equal to 0 तो 0 by something तो limit h tends to 0 by something is equal to 0 तो limit of constant is constant limit of constant is constant. So f dash minus half is 0. Therefore f dash minus half is equal to what? 0. f dash minus half is 0. Similarly RHD, so f dash minus half plus is equal to, use the formula limit h tends to 0, f of a minus a plus h, a means minus half, minus f of a divided by plus h is equal to limit h tends to 0, f of minus half plus h, f of minus half plus h means 1 plus point value, 1 plus, this is square means this is a positive value, so 1 plus point value, so 1 point something is equal to 1, so square bracket कौन आसियो 1, so 1 minus f of minus half also 1 divided by plus h, this is plus h, so is equal to limit h tends to 0, 0 by h is equal to limit h tends to 0, 0 by something is equal to 0, is equal to what? 0. Therefore f dash minus half plus also what? 0. So LHD 0, RHD 0 as f dash half minus is equal to f dash half plus is equal to 0. So f of x is differentiable at x is equal to minus half. So f of x is differentiable. So f of x is differentiable at x is equal to minus half, as fx is differentiable at x is equal to minus half. This implies fx is also continuous at x is equal to minus half, because every differentiable function is continuous, hence no need to test whether it is continuous or not, no need to test for continuity. कहीं ना जेहेतु फंक्शनटा डिफरेंशिएबल हो जाइए तो कंटिन्यूटी चेक कर आवश्यकता ना, तो देयरफॉर फंक्शन इज आल्सो कंटिन्यूअस. और मन रख एनी स्क्वायर ब्रैकेट फंक्शन जदि डिफरेंशिएबल है तार भैल्यूटा कौन आसो 0 ही आसो एनी पॉइंट रे, मीन्स जेकोसी पॉइंट यदि फंक्शनटा डिफरेंशिएबल स्क्वायर ब्रैकेट कौट डिफरेंशिएबल हम, स्क्वायर ब्रैकेट फंक्शन डिफरेंशिएबल एट x is equal to a if f of a स्क्वायर ब्रैकेट f x ना, तो f of a is नॉन इंटीजर, f of a नॉन इंटीजर होची ताले स्क्वायर ब्रैकेट f x टा कौन हम डिफरेंशिएबल हो एट x is equal to a and its value is 0, Next question. Another one. F of x is equal to, again same, test the continuity and differentiability of the function. Test the continuity and differentiability of the given of the function f of x. Another one. F of x is equal to x into square bracket x into square bracket x comma 0 less than equal x less than 2 and x minus 1 into x minus 1 into x 2 less than equal x less than 3 at x is equal to 2, test the continuity and differentiability. Test the continuity and differentiability. Solution f of 2 means x is equal to, so x is equal to, so here put x is equal to, so 2 minus 1 into 2 is equal to 1 into 2 is equal to 2. This is the value of the function, value of fx at x is equal to 2. f of 2 minus h, so is equal to 2 minus h means x is less than 2, x less than 2, so put here x is equal to 2 minus h, 2 minus h into square bracket 2 minus h, so is equal to 2 minus h, square bracket 2 minus h is 1, saying 2 minus h is less than 2 but greater than is equal to 1, so square bracket 2 minus h is 1, so is equal to 2 minus h. Next f of 2 plus h, f of 2 plus h means x greater than 2, x greater than 2, 2 less than x means x greater than 2, so put here 2 plus h, put here 2 plus h, 2 plus h minus 1 into 2 plus h, so 2 minus 1 plus h into 2 plus h, so is equal to multiply this 2 plus 2h plus h, 3h plus h square. This is f of 2 plus h. LHD at x is equal to 2, at x is equal to f dash 2 plus is equal to limit, use the formula h tends to 0, f of 2 plus h, 2 minus f of 2 minus h minus f of 2 divided by minus h, so is equal to limit h tends to 0. What is f of 2 minus h? F of 2 minus h is 2 minus h, 2 minus h minus f of 2, f of 2 is 2 divided by minus h, so 2 to cancel, so this is limit h tends to 0 minus h divided by minus h, cancel, so is equal to limit h tends to 0 1, so limit of constant is constant, so f dash 2 minus is 1, f dash 2 minus is 1. Next to find f dash 2 plus RHD at x is equal to 2, so limit f dash 2 plus, so is equal to limit h tends to 0, f of 2 plus h minus f of 2 divided by plus h is equal to limit h tends to 0. What is f of 2 plus h? F of 2 plus h is this, 2 plus 3h plus h square minus f of 2 is 2 divided by h, 2 to cancel, so this is limit h tends to 0, 3h plus h square divided by h, so this is 0 by 0 form, so taking h is a common from LHL numerator, so this is limit h tends to 0, h common कर ले 3 plus h divided by h cancel, so this is limit h tends to 0, 3 plus h, put h is equal to 0, it is 3, so f dash, therefore f dash 2 plus is equal to what? 3, so f dash 2 plus is equal to 3, f dash 2 minus is equal to 1, both are not equal but LHD exists, RHD exists but not equal, so f of x is non-differentiable at x is equal to, so f of x So f of x, f dash as f dash 2 minus is not is equal to f dash 2 plus. This implies f of x is non-differentiable at x is equal to 2. तो फंक्शन टा डिफरेंशिएबल हेलानी एट एक्स इज इक्वल 2 रे. जदि डिफरेंशिएबल नुहे आमको टेस्ट करिया पड़ियो कंटिन्यूटी. टेस्ट द continuity of fx at x is equal to 2. तो एल चलाना सॉरी f of 2 is equal to what? 2 into square bracket 2 into square bracket 2. तो is equal to 2 into 2 means 4. f of 2 is LHD at f of 2 means this is 4. Sorry. This is 4. f of 2 means ठीक है. f of 2 is x is equal to 2 minus 1 into 2 is equal to 1 into 2 is equal to 2. f of LHL at x is equal to 2. तो लिमिट x टेंस टू 2 माइनस fx. लिमिट x टेंस टू 2 माइनस fx. तो इज इक्वल टू लिमिट h टेंस टू 0 f of 2 minus h is equal to limit h टेंस टू 0 f of 2 minus h. x is less than 2. x is less than 2. Put here x equal to 2 minus h. 2 minus h into square bracket 2 minus h is equal to limit h tends to 0 2 minus h. This value is 1. Square bracket 2 minus h is equal to what? 1. So put h is equal to 0. So 2 minus 0 into 1 is equal to 2. So LHL is equal to what? LHL is equal to 2. LHL. So therefore LHL is equal to 2. Next RHL. RHL at x is equal to 2. So limit x tends to 2 plus fx is equal to limit h tends to 0 f of 2 plus h. x जगह 2 plus h पकेबो आउ एटा को ठीक री h tends to 0 करिवो. तो इज इक्वल टू लिमिट h tends to 0 x greater than 2. x greater than 2. x greater than 2 means what is fx? fx is x minus 1 into x. So put here 2 plus h minus 1 into 2 plus h is equal to limit h tends to 0 1 plus h into 2 plus h. Put h is equal to 0 because this is not in 0 by 0 form or infinite by infinite form. Therefore put h is equal to 0. So is equal to 1 plus 0 into 2 plus 0 is equal to what? 2. Therefore RHL equal to hence limit x tends to 2 minus fx is equal to limit x tends to 2 plus fx is equal to f of 2 is equal to 2. So f of x is continuous at x is equal to 2. So f of x is continuous at x is equal to 2. Write down f of x is continuous at x is equal to 2. Okay.